where they set the window in. There's a rough opening of a frame, and they set the window in there, and they actually jiggle around with it with little wedges and get it set. Most people don't realize a window moves a little bit, and if you don't set it level and right, especially if it's a double hung window where you have the slider part, it will not open correctly, and it could possibly cause some air leaks because it's sort of kicked out of whack. So if you do it correctly, you have to set that window at a perfectly level so it's not jerked around or twisted or warped or anything. So you use little wooden wedges, and once that's all set, then nail it home and it's set. But they don't always take the time to insulate, and you'll have gaps between where the window meets the wall or the frame. So just take your hand and stick pieces of fiberglass bad insulation in there, poke it in there, and if it's not done carefully, it's a huge air leak. So to strip that molding off and go back with Stuff It or some type of foam insulation that you can purchase at Home Depot or Lowe's, and there's a little nozzle on it, you can just actually fill in the cracks and it swells up. It's extremely good insulation and it seals everything up. The older materials used to swell so much it would actually bend the wood, but they quickly developed a stuff that wasn't so powerful that it did that. So it's not all that expensive. It might be $9 a can. But these are little things you can do to go around and analyze the windows and just see where you've got leaks. In a conventionally built home, we assume where the leaks are going to be. The windows, the doors, corners and all that. But we don't know for sure. I mean, there may be other places, outlets where the ductwork connects to the floor, the outlet plates. In northern climates, where cold is really prevalent and severe, they installed rubber gaskets behind the wall plate that actually insulate the plugs. They have little plug covers for the actual outlet holes because the air can come through there. And so it's no big deal when you got one, but when you've got 37 of them throughout the whole house, it adds up. So what has been developed over the course of time is what they call a blower door test. Duke Power does it. And I initially contacted them to do it, but they do not do mobile homes and they do not do manufactured homes for whatever reason. They only do conventional houses. What happens is they actually remove the front door and they install a panel on there. It's a flexible panel that has a huge fan in it. The entry doors are 36 inches, so this thing's like a 34-inch diameter fan. It'll fit anything. So they get it up in here, they connect it to the door jamb, and basically turn the fan on and draw a vacuum on the whole house. It just sucks the air out of the house, and in that way they can tell where the leaks are, because what's happening is it's just forcing the air to come in from the outside wherever it's easiest for it to come in. There's different ways of doing it, but they can take smoke sticks, for example, and go around the whole structure and figure out where the leaks are. Not only do they figure out where the leaks are, but they figure out how bad the leaks are, because if they know how much air is going out by calculating the cubic footage of the house, and they have a vacuum gauge so they know how hard that suction is pulling. If there was a lot of holes in the home, the vacuum gauge wouldn't be reading that much because it's easy for the air to come through. As you make the holes in the home smaller, the vacuum gauge reads a higher level so that you know that the holes are smaller and smaller, so they can basically use all this information to ascertain whether the home is an awful leaker or pretty okay. So that's sort of the artificial way of doing it, but it's an extremely good test. And it really isn't that expensive. I think the $200 test, but it really, their game plan is to, okay, once they've identified these leaks, then they come in and work up a contract to say, okay, we can fix all these windows, or this door needs to be replaced or fixed or whatever. So that's their end game, but which is all good. That's basically their business, is to identify and then repair leak problems in the home. You can do the same thing without the blower door test on a windy day, especially, ideally. Just incense or a punk stick or something, just have the smoke come off, and as you pass in front of the windows or the outlets or anything, you can see that smoke will change direction. It'll get pushed into the direction in which the wind is coming in. Very inexpensive, very accurate as far as identifying where the problems are. And that means going around the corners, going up here in the corners, going around all the window things, going around the duct leakage is actually a fairly serious problem. So they will seal off the ducts and then sort of look at the difference between when the ducts were sealed and when they weren't sealed to see if the house leakage is in the house or in the ducts. And they can sort of narrow everything down that way. And that duct leakage isn't passive leakage. That's when it first starts, it's coming out strong and hot, and then by the time it gets through the thing, 25% of it's going into your crawl space. That's not doing a whole lot of good. Identify where it is and fix it. And you can actually go through each individual length of duct and test it that way, and that's that's what they'll do. Getting a contractor to come in and do the blower door test, or even Duke Energy to do it, it's a good investment. So
do you know what the number is for this house?
We didn't do the test yet. We will do it. I wasn't too worried about it because, as I said, the manufactured homes are usually a lot less of a problem than a conventional home. So in this home, it's probably going to be around the windows. That's only because the house was moved. Windows are bound to loosen up. Now they'll go back and fix all that, but I mean it doesn't always mean that it's going to be perfect. Does anybody have any particular questions so far? Because we're going to go through and I'm going to walk through and do everything, you know, in detail. Every area we've done here in the home and everything, but
we have a super insulated house,
uh-huh.
and so she keeps something boiling or just trying to get moisture into the air.
Simmering, yeah.
Yeah, and is that enough?
It can be, and especially in a really well-insulated house, it can be. I'm referring to north again because that's where they really have extremes of these kind of problems. Minnesota is a great example because they have the university up there has done extensive research into exactly super efficient, super tight homes and the problems caused by that air quality and moisture issues as it relates to damage to the actual structure. In this case, what we're doing is venting in a very conventional way, venting the moisture out, you know, out the wall or, you know, ceiling, whatever it's going to be, like a bathroom vent. When it gets to the point of a super insulated house, they will install what they call an air-to-air heat exchanger. They'll vent the moisture, but it also brings in fresh air from the outside and at the same time conditions that air so you're not pulling in cold. Anytime we breach a wall or the roof and we're sending air out, you're also sending heat out. That's a loss. In this climate, it's not a good thing, but it's a trade-off. It's an acceptable thing. We're not so extreme here that we have to worry about it too much. Having healthy indoor air and having a long-term situation where you're not encouraging rot to happen in the walls where you can't see it or mold to build up is better than worrying about the small amount of energy you're going to lose when you cook for that 45 minutes. But in Minnesota, for example, they will use the air heat exchangers, and what that does is warm air from the house is going out of the house along with the moisture. But that tube that sends it out is encased in another tube that's larger, and the space between the little tube and the big tube is the incoming air. So as the incoming frigid air from Minnesota, you know, the 11 degree below zero air is coming out, as it passes over the air going out, as it comes in, it gets warmed up. And by the time it comes in, it's not warm, but it's a lot better than minus 11. So that's how they work it. These are mechanical devices that in this climate would be not a wise use of all that energy and money. Up there, it would be a good use. Now in a house that's wood heated, where you have a lot of dry air, your wife's situation would be okay. You can do a testing of humidity levels right around the stove, you know, around the kitchen. It may be that even if we have a wood stove over here and the air's dry, you may still be dumping too much moisture there, but you can resolve that with say a ceiling fan or something just to move the air around a little bit and get it, you know, get it out of there. And they do make over the transom discrete little very low power fans that transmit air. You know, it's all up here where the hot air tends to migrate, that will move air from room to room if that's the situation. And if the kitchen was more or less enclosed, you know, more separate than a normal open kitchen, and you could get that moisture into the next room where the wood stove was, that would be, you know, that would be good. Now you don't have a wood stove, or I don't think you do. So, or you didn't say you did.
Took it out.
Yeah. Okay.
Some of the wheelchair, and he kept running into it.
Wood stoves are positive and negative, and we can talk about that a little bit too. It's really nice to have a smaller group because that way we actually can do this. Why did you come here? Is there anything specific that you needed to know about?
What do we got to do to build a building that is energy efficient, self-sufficient, possibly off the grid? And that's what I'm looking at right now because I have a piece of land that I want to build on.
Yeah.
And there's so many decisions to be made. So foundation materials and foundation insulation is something that I'm interested in. Also, in the building I'm currently in, I don't have any foundation insulation, and I had somebody come out who gave me a consult, and it didn't seem like it was a realistic answer for me. So I'm still looking, I'm still open to those kind of things. Insulation is my big thing right now.
Yeah.
I want to insulate everything.
Yeah, okay. And you're talking about foundation, the structural foundation of the home, the tie between the house and the earth. There's perimeter foundations, there's slabs, there's other things, so it sort of depends on which you're going to use, but all of them have some type of resolution. So, okay, well that's a real good point. Passive solar design is a whole other topic. It's all connected, but that's a whole day's worth of workshop. Maybe one day we'll do that too. I've taught one of the passive solar design courses at the Mother Earth fairs, which we were just talking about.
We've already mostly talked about older home.
Yeah, resolution for problems of older homes, which brings its own challenges. Once you introduce insulation into a home that was never insulated, it can introduce a whole new set of problems, mainly related to moisture. So you have to be very careful about what kind of insulation you choose and how it's applied and how it's installed.
Some of the disability we want to be able to take care of. I mean, if there's a problem with the grid, or if just a natural disaster. But secondly, on a larger scale, I work with about 400 elderly people in a small community, and we also do some construction and things like that we might be able to be more responsible with how we build, and also, this also is part of taking care of and protecting them.
Yeah, health-wise, and also just good energy management, so we're not squandering resources, financial and otherwise. Almost everybody will think of, when you talk about energy, will think of how much it costs, but that's also directly tied to waste of not just money resources, but natural resources
we build. I mean, we do a lot of building ourselves.
Yeah.
It's like running a small community. We have to repair water leaks.
Yeah.
We have crews that dig things up, and so a lot of what we're doing now is the foundation for the future for this little community, and we can just be more responsible and try to take things a little bit different direction.
Well, that's something a nonprofit, say, like Habitat for Humanity, they have that path to follow too. I mean, at this point, there are nonprofits that are set up to help people in lower income brackets get into their own housing. Now, if you're in a bracket where there's not a lot of disposable income, you also think, okay, why burden them with high energy costs on top of a mortgage? So the point of building as much energy efficiency into the home and appliances from the get-go is going to just help going forward. And so it's an education process plus a choice. So that's that's a good point. And you wouldn't believe how difficult it is to sometimes get that point across, to people. I mean, why are we spending $700 on a refrigerator that I can get the one the same size for $590? Well, you're also going to be saving energy every year. You're going to be saving that much more energy on the more expensive one, and in 3.5 years you're going to pay the difference, and you're going to be going forward saving money. The cost of energy is not going down. I mean, and having said that, of course, now we see gasoline prices, but that's a very short-term blip in the landscape. That's not a normal. Going forward, the cost of energy is going to do nothing but go up, and so by planning for things now, as far as efficiency goes, that's always something to remember. The price of a gallon of gasoline at this point is pretty close to $9 a gallon, realistically. If you incorporate the cost of the defense system it takes to protect our oil reserves, where it's coming from, just the damage to the environment it takes, the cost of achieving a barrel of oil is so much more expensive than it was, say, in 1960 or 70. And every new source of crude oil is deeper, it's harder to get at, it's harder to extract, it takes more equipment and knowledge to get it out of there. So every single year as we go forward, it's more difficult and more expensive to get that barrel of oil out. So the price is not going down anytime soon. More recently, people have said now the natural gas is dwindling in supply. Well, that was before the fracking epidemic. But when you factor in the cost to our water supplies of the fracking, I mean, that's a very, very serious situation. And people who are making decisions who should know better are not, I don't feel, are making the right decisions in some of those cases. So it just seems strange that something as precious as water, they're saying we don't have any proof yet, so let's just keep on doing it until we see a problem. And you can't fix groundwater. Once it's contaminated, it's not really easily repaired. I mean, it's difficult. So unfortunately, the amount of natural gas that's come in the market and driven the price down is also a very temporary thing, because it's risky to the groundwater and the fact that if you had analyzed site by site in the shale oil sources, they would estimate that there's so many therms of natural gas contained in this bunch of rock here, and it's not always panning out that way. And so they've spent oodles of money in getting it out there, and all of a sudden they expected 15 years supply and it's only 7. And all of a sudden so they pick up and move to someplace else, and they sort of brush that part under the carpet. So that's, it's an energy management issue. And unfortunately so technical that a lot of the general public just doesn't, they didn't get the memo. They don't get the memo. It's out there, but it's not being absorbed. What I wanted to do was talk a little bit about the kilowatt This is manufactured by, I think it's E3 Corporation, I believe it is. This is the kilowatt, and there's also another company that makes a similar product called Watts Up. I think I paid $24.95 for this. I think you can probably get them with a little searching online for about $16. You plug it into the wall, and then you plug your appliance into this, and it will read a variety of factors, and it measures voltage. And the reason we want to measure voltage is the power companies are supposed to be generating power within a certain voltage range. It's supposed to be generating what they call 110 volts to 120 volts, somewhere in that range. When it falls below, at the lower edges of that or below, it's what they call brown power or dirty power. It's a weak voltage situation that actually can be damaging to your refrigerators, especially the compressors and the motors and refrigerators don't like that. Computers don't like it, and it can actually do some damage. So there are situations where people have had to replace refrigerators and freezers and other appliances due to low voltage, where they would go to the power company and say, your lack of providing the proper power has caused damage, and the power company says, no, it wasn't us. How do you know? Well, now we know. You can actually measure it. So, whether that's going to get you a new refrigerator, I don't know, but I mean, you actually have documentation now. So the other thing is surges. I've had not non-lightning surges, actual power surges where it comes through. I've lost a range hood and a refrigerator because of that. And again, that's measurable. So this thing's it can measure voltage by initially setting up the menu and going through it. It'll measure a variety of things, and one of them is voltage. One of them is the wattage, and the wattage is how much power the device uses. So you can actually see if it's a 100-watt bulb, it's going to draw very close to 100 watts. That's a lot of wattage. That same bulb in a compact fluorescent, when I say same, I mean the same lumen, same amount of light coming off of it, is going to be considerably less, say 26 watts. It's going to be, put out the same amount of light using only 26 watts for what the old bulb would have used 100 at. When we get the third kind of light, the light-emitting diode or LED, for that same amount of lumens or light, we're getting down for lower than 26 watts. It could be 10 or 12 or something like that. So every bit of savings in wattage will be reflected on this meter. So we can plug 3 different kinds of bulbs into here and see the difference. If you've got 10 light bulbs at 100 watts, that's 1,000 watts of energy, or 1 kilowatt. You burn those lights for 1 hour, that's 1 kilowatt hour. That's how we pay our power bill. We use 456 kilowatt hours this month. So now a kilowatt hour isn't all that expensive, but when you start adding it up, it makes your bill go up. I think I have this set up for 12.4 cents a kilowatt hour because that's what the average national rate was. I was teaching a class and I was just using a national average rate. I think at this point, for the residential service that I have, which probably all the rest of us have as well, at the level at which I use it, because they have a different rate charge for businesses, for small business, for medium business, for big business, for industrial, all different tiers of kinds of use. But for most of us, it's residential, so it's at 10.4 cents a kilowatt hour is what my normal bill is. So if you've got 10 100-watt bulbs going for 1 hour, it's going to be only 10.4 cents. But when you talk about that over a period of a month or a year, it starts to add up, and that's just those 10 light bulbs. And then we've also got the refrigerator, the electric stove, the dryer, the hair dryer, the microwave, and all that. So it all adds up. So we got that measurement, and then we can key in the cost per kilowatt hour. Like if this was in, for example, San Diego, California, that cost would be about 23.6 cents a kilowatt hour. They have very expensive power there. If we were up in Puyallup, Washington, where they have a lot of hydroelectric, that cost could be down to maybe 7.8 cents or less. The hydroelectric power is a lot cheaper than coal-generated power. So this machine has to be able to work in any part of the country. So we have to plug in, get in the menu there and plug in the cost per kilowatt hour for your power company. And once we have that figure, we can select the cumulative kilowatt hour cost per minute or per hour, as it builds up, and which is what I did for the refrigerator here when we're doing the testing to see what to see what kind of consumption we had. And so I left it in there for about 2 weeks, and then I just extrapolated it for the month or for the year. And I think I gave you the figures on that. And we just figured out that it uses a certain, I think it was $97 a year. I think I had to look at my notes, but the new refrigerator is going to be using somewhere. Well, we haven't really picked exactly what we're going to do, but it's probably going to be somewhere around $54 a year. And they give you the U.S. version of it. There's a Canadian version and a U.S. version of the energy label. But the energy guide label, when you buy an appliance, it'll have the big yellow sticker you usually see on there. It'll have it in kilowatt hours per year, in dollars per year to own it and operate it, based on a 12.4 cents a kilowatt hour rate. And then it also gives you a sliding scale, so it has of that size refrigerator, for example, it'll show the most expensive one is, say $136 a year, and the least expensive one is, say, $49 a year, and then where along that sliding scale this particular model is, and it'll have a little arrow. We can set this up to actually cumulatively read the cost per month or day or whatever. It just adds it up and stores it, so you can actually figure it out. There's 2 or 3 other functions on here that we don't have to worry about, but it's good for like engineering types that really need to figure out power factors. And power factor basically is like how efficient the motor that we're plugged into is using the power it's given, that kind of thing. But we don't have to worry about that for what we need to know. And what we need to know is voltage to some extent, but probably the most important thing to know is the wattage being consumed, and as a function of that, the kilowatt hours being used in the device. So basically, especially at $24 a pop, you could probably buy a few of these and plug them in. It's only one at a time. So we have one maybe on the refrigerator, one on maybe you'll want to know how much your dryer is absorbing or how much your microwave takes or something like that. So we could buy a couple of them and start adding things up and see if it's worth it. Once you know what you are using, like the refrigerator is probably the best use of something like this. You may be at the point of your refrigerator's maybe not even really that old, but you suspect that it's using more power than it should be, or maybe there's something going wrong. Maybe it's sweating, something going wrong with it. It's not keeping cool. Or you have to fool with the thermostat, with the dials more, or there's some problem. And you're getting a thought. Well, gee, is it worth it to fix this, or replace it? And with the use of this meter, I can get rid of that 6-year-old one, which may not last another 2 years or maybe 4 years, but in 4 more years, it's going to be eating up, $50 more a year than this one I'm thinking of buying. And how much can I save over the long term with the new refrigerator? And that's, it's a decision-making tool. So we can use it as a calculator to figure out how much is it worth it to buy a new refrigerator. And the other thing is you can look at smaller ones. Some people have a lot more refrigerator than they need to, and they might want to step down a notch, go from, say, a 21 cubic foot down to an 18.2 cubic foot and save that much more energy and just use the space a little more efficiently inside. And that's always a good thing. Yes?
We don't really know the optimum way to use them. I mean, I remember when we bought the refrigerator we have at home, it pointed out how not to put material against the sides,
exactly,
against the back, and we lost track of that a long time ago.
Yeah.
And so we're costing ourselves just by the way we use it.
Yeah,
that
exactly.
Would be true for any number of things. Certain utility companies.
All of them, really.
Okay.
Yeah, all of them have a program.
Rates
Yeah.
at certain times, so it's more a matter. It's partly too how we use things.
Time of use. You can go on what they call a time of use program. In other words, the power company. When I say all of them, some of the little co-ops or maybe some arcane little place in Nebraska or something. Maybe not. But I mean, for the most part, the power companies will offer you a variety of plans, just like the phone company will offer you a variety of plans. You can do a time of use plan where they bill you at a totally different rate because you have agreed to use your certain appliances in off-peak hours, which is like after, usually after, well, it depends on where you are, but after 8 o'clock or something, between the hours of 8 and dawn the next day or 5 the next morning. And in fact, they have situations where they remotely control your water heater, your electric water heater, and your dryer, and maybe your heat pump, some of the other things. They can actually wire those circuits up with your cooperation, in which they will shut those things off during the times where their peak use is severe for them. Like in California is another, it's a perfect example because they're always having problems with power generation. When you have that program, you just can't use your dryer, it just doesn't work in the daytime. You have to wash and dry your clothes at night, because that's when the power use is low, and that's when they can afford to sell you the power at a much cheaper rate, because you're not hurting them by asking for it when everybody else wants it for their air conditioners. So those programs are available, and they're generally hooked up with big consumers like dryers, washing machines, electric hot water heaters, things like that, so that if they can get so many thousands of people to agree to pull those appliances off their peak load times, that's all the better. So that actually, if everybody would cooperate, that has actually saved or stopped the building of one more power plant, because it doesn't take much conservation to reduce the need for an entire power plant. I mean, it doesn't sound right, but it actually is, because a lot of the power plants they are building now are what they call pocket plants. They're smaller plants, but they're just really needed to fill in. What they normally do is they buy. It's a cutthroat industry, and what they do is they have to make a decision: should we invest in an area like this, for example, where you have a lot of people moving in rapidly. Historically, people haven't moved into an area they'll dribble in, but they won't. But in some places like here, Lake Tahoe in California was a good example. Other places where a destination has been discovered, quote unquote, and people start flooding in from outside, all of a sudden the power companies here, what are we going to do? The building craze is here, and we're not able to feed it. And so they have to make a decision: do we need to build a new power plant, or the only other option they have is to buy power at obscene rates, even at wholesale level. It's like I don't know, like chickens. When the chicken gets pecked at and a little bit of red shows, all the other chickens go after him or her. And the same with the power companies. When they know that San Diego, that Pacific Power and Electric is in desperate need of power, they'll be glad to sell it to them at 37 cents a kilowatt hour, in which they have to charge. They can't pass that cost onto the consumer, because the Utility Rates Commission doesn't allow that. So they have to eat it, and the shareholders don't like it. So they have to really manage this and think: is it worth it? They have to look at population growth trends and building trends, and is it worth it for us to invest in a new power plant, or just to buy from these other guys, and maybe we can work out deals where we can supply, maybe in certain times of the year we can be supplying to them, and they won't be so vicious to us when we need it. So you're buying power from this grid is a huge network, and they can feed and redirect as they need to, and so it just depends on how bad you need it, or how bad the power company needs it, and what they're willing to pay for it. And also there's a lot of political stuff going on, because if American Electric Power gouges Pacific Power and Light too often, they may be in a situation where they need it down the road, and then Pacific Power and Light or some other people are gonna say, well, these guys were vicious, they were pirates, and we're gonna give them back some of that. So they have to think politically about how astute it is to be dealing like that. So it's a big game, and in fact, well, I think it was a pretty big news story back in probably 2005 or so in California. Remember we had the massive blackouts and brownouts where the traffic lights would be, in California when there's no traffic lights, it's a major deal. I mean, people have been killed just in, it's fatalities, injuries, all sorts of stuff. So because of the traffic situation, and just because there was some finagling going on in just the way these power packages were manipulated. I believe there were some investors that wanted to see how this could be controlled, and they basically just did it. And he said, well, you want to see? We'll just do it. And they did it. And I think the famous line was, so you mean I'm shutting off, I'm cutting power down to a nursing home at this point, just for demonstration purposes? Because absolutely, we can do that. I mean, they can't individually shut off a customer, but they can shut off a whole region. And that's what they were doing. They were shutting off this. They were robbing Peter to pay Paul just for a demonstration of how we can manipulate this stuff. And you know, this you can go from you know, they pull power from Arizona or from Florida, whatever they need to do and whatever they have to do. So it's all a very big business, and it's all very, you know, manipulated, and that's a good argument for not really a discussion for today, but less centralized power production is actually a good idea in many cases, because it gets away from that huge, massive, manipulated system and keeps it more on a local level where you can control it more. And then, you know, the other end of that is really as it gets down to the individual homes where, you know, many people are just off the grid entirely, and they have no connection with the utilities, and they don't want it. And, you know, my friend Rob Roy in upstate New York has a building school up there and has lived off the grid for probably since the mid-70s, I guess. You know, they have neighbors and people who, you know, are talking about they go to the grocery store and say, oh, the power, you know, the utility's been out for 3 days, and he's like, oh, really? I didn't know that. You know, he's like, you know, thanks for letting me know. You know, they just don't have those problems. And of course, the other end is you do have problems. You have maintenance issues. If power goes out, he has to climb up his wind turbine tower and fix it. You know, 110 feet. He has to go up and fix it if the problem's up there. He has to scrape the snow off his solar panels. I mean, it's all on him now. But you know, that's the price you pay him. It's a trade-off. You know. But they call that distributed generation. So when it's actually done on a smaller scale, it becomes a little more personal, and people become, all of a sudden, it's not us against the power company. It's just us. So we will fix it, and we become a lot more communal in how that's dealt with, and people tend to get a little more cooperative, and you know, it works you know, pretty well, really. And when you've got a small enough group, it has to be big enough to work, but small enough to where everybody sort of knows each other in a cooperative sense, and you know, it can work very well, and it has. There have been towns in the wind generation field, for example, where there have been communities who have actually invested heavily in their own power companies based on wind, not exclusively, but based on a large input in wind investment, where they've actually been able to sell excess power at certain times of the year back at pretty good rates back to other power companies that are not investing in wind, and that's how they've paid off their wind turbines, paid them down pretty quickly. It's like paying down your mortgage early. I mean, they didn't realize you know, it's dependent on the weather, but there are good times of the year when the weather really sends a lot of wind your way, and they've paid off those investments, you know, in short order, and hadn't really counted on that. But they could, a couple of towns, I think along the Mississippi River, and in the area along, you know, in the upper Midwest, where they've, you know, actually done pretty well with it, and that's where the wind works best. So, but if I brought my lamps, the reading now it's at 13.9 watts, 14 watts. I assume this is probably a 15-watt bulb. It might be a 13. It just depends, because it fluctuates. They're all different. Manufacturers are different, but that's the point. We're getting the same amount of light for a lot less energy being consumed. And then we're going to go in here and take this one out. It's a 60-watt bulb. The point is to have an incandescent bulb that is a certain amount of watt, like 100 watts, and it throws out, say, 900 lumens, which is the measure of light. And then we find a 900 lumen compact fluorescent bulb that has a significantly less amount of watts. It might be a 13 watt or not 13, 26 watt usage, but still gives the same amount of light. And then we'd have a LED light that throws out the same amount of lumens and uses even less wattage. And we can just read that on the meter, but we're just going to have to live with it. You get the idea. So that's a 60-watt bulb. What we do, we've plugged the power strip into the power source here and turned it on. Then I plug in the kilowatt meter, and it's showing. You can come by here and everybody can look. At this point, it's showing that it's right at the upper range, so that's excellent. Not too high and certainly not too low. That's a 60-watt bulb. It's actually drawing 59.9, 60. It'll vary a little bit because it's getting hotter. You know, but it's you know, right now it's perfect. I mean, it's a 60-watt bulb, and you can see we're at 60 watts. The wattage indicator's over there, so we're 59.9, 60. It's just changing. Okay, so that's that. Now we can unscrew this. And it's hot, but we can still unscrew it. Mm-hmm. There's an LED at slightly less equivalent wattage, but it's probably gonna pull. Okay, that's 6.7. Now you can see that 6.7 watts. So that light is not quite as much as those two would have given out, but it's pretty close, and it's still pulling in. What were we at before? 13.8 or something. So that's like half, 6.6. That's not a bad quality of light. Put the top on. We can leave that one in there probably. That pretty much looks like what what you had in the first place. Maybe 8 years ago, that light would have been almost all up here, like probably 60% of it, if not more, would have been in this 30 degree, maybe 30 or 40 degrees out here, and you wouldn't be getting much down here, and that's where you really want. I mean, you do want it out here too, but you'd like to be able to use this as a workspace. So what they've done is they've improved the diodes, they've improved the position of them, they've improved the angle of reflection within the bulb, and they've shielded it or unshielded it. So they've done a lot of things to improve that. So for a general illumination bulb, these LEDs have really come a long way, and the costs have come down, and they're just going to keep on, coming down till they get to some level of,
I looked at one
stability.
They had different choices of colors.
Yeah.
And the one I got felt more like I'm looking at a acetylene torch.
Oh, really?
It's
Yeah.
really white.
Let me explain that part. Compact fluorescents did not used to be dimmable. Many of them are, but not all of them are. And the other part about LEDs is that you have to read the label to make sure it's indicated for outdoor use if you intend to use it there, and also, more importantly, for moisture conditioned areas. So if it's either outdoors or places like over the stove and stuff where you have moisture, the bulb has to be approved for that. So you have to read that on the label. The main thing I wanted to point out was a bar graph on here, and it's the Kelvin level, which has to do with the color of the light. The warmer end of the scale is about 2,500, and the higher end of the scale is going to be over 4,000. At the low end, in 2,700 end, which is what this bulb is, it's going to be a yellowish, comfortable, warm light. Not as much brilliance, but a comfortable, soothing light. If you get up to the 4,500K level, it's going to be a harsh blue, very stark light. And then down below that, at the 3,000 level, it's going to be what they call natural daylighting, somewhere in there. So you're going to have those three options in the same bulb. I mean, given, you may not when you're actually in the store, but I mean, the manufacturer makes it available, most likely. Say at Home Depot or Lowe's is probably going to have a chart on the, I know Lowe's does, on a chart on the wall where it'll sort of show you what the light looks like in a picture on the bar graph. So it'll be that warm glow, the natural daylight, and then the more blue, I guess they call it cool white. So, you can pass the box around, you can see it. I'll start here and just pass it.
And so the daylight one is like full spectrum?
They're just saying it's more like a natural light, but without claiming that it's a full spectrum bulb. That's all. Reading with a much more intense light is going to be helpful, whereas some people it just gives them a headache. I've seen demos in stores, you're actually looking at what you're going to get. This particular one, I don't know if it was $897 or $847 or something like that, but there are bulbs that are, as you get up in wattage a little bit, they can be, $14, $19, and some of them even $40. But when you spend that much, you don't want to take it home and find out that you've got one that you really can't live with. We were talking about conservation, which is very important, and Pat, Pat has been drumming it. Every time we talk about this class, we have talked about this class or any kind of a discussion about workshops, he always drums home the fact that, conservation, conservation, conservation. He keeps the house here at 55 degrees when nobody's here. Even, I was working in here and, we just kept the thermostat down at 55. And even in the week, even when you are here, it's like 63? I mean, not... Usually when he's just moving around, it's 63. Yeah, 63, yeah. And, I do the same thing. It's a little bit of a sacrifice, but it's not awful. I mean, I cut a lot of wood. I heat with wood. I cut a lot of wood. I'm usually, have body heat, and I'm not lounging around a whole lot when I'm home. I can keep the house at 60 and it doesn't feel bad. I have people come in and say, "What's the matter with your furnace?" You know, it's like, nothing, it's not working. It hasn't been on in 4 years. It's great. So conservation is important, and that may occur to have some training for family members. I mean, you sort of get into that mode of we can wear a sweater, we can do things to sort of, you know, fend off that. The house doesn't have to be at 60, but I'm saying it certainly doesn't have to be at 72. So that's one thing. The other thing is things like light bulbs. If somebody complains a lot about having to go from a lit room into an unlit room and constantly have to feel for the light switch or whatever, they do make motion sensors that you can buy. They're not that expensive. For something as little as the ones that would power a small light bulb, they're not high amperage. They don't need to be heavy duty, so they're fairly inexpensive. And you can install them for lamps. When you walk in, the light goes on. When you it goes off after a certain amount of time, or when you walk out. So usually it's on a timer. The lights here in this, the spotlights, the floodlights for the outside in the corner of this house for the driveway are on a 4-minute cycle. So that, well, when I installed the LED bulbs out there, I tested it, and it said, there's a switch on there, it says, I guess it says on 4 minutes and 10 minutes or whatever it is. I checked the 4-minute one, which is where he wanted it, and you know, sure enough, after 4 minutes, the light went out. So that's, you know, that's how it works. That saves you the fumbling around for the switch or whatever. It also may be on longer than you want it to be if you're just going to pop in the room and pop out, but it's certainly better than leaving the light on in that room forever, you know, for the whole night. So things like that, thinking about that just lifestyle transition into keeping the lights off unless you really need them. In addition to going around the house and choosing the kind of lighting you need for certain areas, and then choosing the correct LED bulbs for those areas. So, you know, you may have task lighting that you want to aim the light on one particular spot, so that would want a LED spot bulb as opposed to a general illumination one like that one. So that's, you know, that's the other part. But that whole conservation factor is just really a big part of the picture. When we get to the plumbing, I can talk about that sort of separately. But you know, all this kind of thing of saving water, low flow shower head, low flow sink faucets, not flushing the toilet. I mean, some people, I mean, that may be an option or issue for some people, but you know, it is possible. Pat has one way of resolving the flushing issue has a little bucket of water, but you know, if you're not that concerned, I mean, the liquid waste can just be, it doesn't have to be flushed immediately. That can stay for a while and get flushed on, you know, I don't mean every 4 days, but I mean, it doesn't have to be flushed every time you use it. It can be done several times a day and you'll still save quite a bit of water. So that's just another lifestyle thing. Conservation is important, but efficiency is even or equally important over the long run, because that is what is going to be saving you that money over the long term, which especially for an appliance is really important, because they'll last, you know, they'll last 8 years, 10 years maybe, like a refrigerator, for example. The additional cost that's put into a high efficiency appliance is more than likely going to pay for itself over a reasonable amount of time. You know, that being well before the appliance has to be replaced. So thinking in terms of that, it really makes sense to, at least when you shop, to be willing to pay a little more up front and get that long-term service out of it at a lower operating cost, because it's not just a lower operating cost in say the next 5 years, it's also that in the next 5 years your cost of electricity is probably not going to be 12.4 or 10.4 cents anymore. It's going to be going up. We've already had a request from the Duke Energy for a 17.6% increase. That's you know, it's not like they're asking for 3%, which is sort of a cost of living. You could almost see that. I mean, that's not asking too much. 17 or whatever it is they're asking is ridiculous, but they're insisting. I mean, it looks like it's going to happen. I mean, it's you know, not a possibility. I mean, it's more than that. And so the cost of power over the next 5 years is going to be going up. So it's a combination of both of those things. So that initial cost barrier has to be, you have to eat it up front to be able to you know, enjoy it later on. And that's especially for things like refrigerators and freezers and dryers. Well, electric dryers are really not a good example because there's not a whole lot you can do to make them efficient. Washing machines is a good example. You're saving not just energy but water as well when you get a high efficiency washer. Let me see what else would be good for that. Furnaces, if you're thinking about high efficiency furnaces, oil burners, gas-fired and LP furnaces. Normal old furnace might be 75% efficient, whereas a modern one might be 82, somewhere in there, 82, 84. And then when you get, like I bought a high efficiency hydronic boiler. I don't have forced air like most people have. I have a baseboard hot water system, hydronic heating system, the same kind they use for in the floors in the solar homes. The furnace for that, you know, paid a little more for it, and it's a little bit of a maintenance, more of a maintenance problem, but it's that is almost 91% efficient. So that really makes a difference at the price of propane, because propane is a non-regulated energy source. In other words, the infrastructure of natural gas and electricity requires that, because it's a utility, it has to be controlled by the utility commission. That means if it's attached to your house with a wire or a pipe, it becomes a utility. Propane is not like that. Propane is sort of a delivered and then it's yours. They have no control. It's just a free-for-all as far as propane goes. So you can call them up, and one day it's $3.60 a gallon. Next day it's, you know, $1.89, and it's just all over the place. So so you never can tell what you're going to pay for in propane, and it's generally higher. So having a furnace that runs on propane that's efficient, it makes a really big difference in your power, in your cost.
So you chose propane for your hydronic heating system?
Only because I have no other options. There's no natural gas where I live. Electricity is obscenely expensive for heating. You know, a heat pump is not all that efficient for. The only good thing about a heat pump, for me and for anybody in that situation, is that it has the forced air system allows filtration of particulate matter. What I have is hydronic, is basically hot water coming out of radiators like you'd have in a church or a you know, school or something like that. You know, have the baseboard heaters, and you can't filter that air. So that's one thing I really wish I would have. On the other hand, to have installed, my house was never built with a heating system in it. So to install ductwork in a house that's already built, it's very difficult. It's doable, but it's very difficult because you have to steal closet space. They have to hide the ducts. You don't really want a duct running through the, you know, through the living room. So they have to hide it somewhere, like in the wall or in a closet. So you end up, I'm used to, you know, closet storage and, you know, storage space, and all of a sudden they have to put in ductwork, and it's going to steal it. So, you know, I figured with just that, in addition to the fact that a heat pump, to get a very efficient heat pump, they're usually fairly high maintenance. When you get the SEER level, it's SEER, which is the level of efficiency of a heat pump. When they get up to the 16 and 17% level, which is highly efficient, they also tend to become, you know, a lot of maintenance calls on them. Not that they're bad. It's just that they have to be maintained. It's like a fine-tuned car. The only other option to think about seriously is ground source heat pumping, which is where they dig trenches in the earth and they use the heat of the earth to provide the heat for the heat pump. And it doesn't make sense because the earth, you know, you've seen snow on the ground, but in general, in the measure of temperatures, absolute zero is actually down below 450 degrees. I mean, it's down, you know, minus. So they measure from that point up to boiling. And so in the scale of which we're used to living, the heat from the earth at generally 55 degrees is actually pretty warm. And the machine, the way the compression cycle works in those heat pumps, it's much more efficient to pull 55-degree heat from the earth than to try to pull it from the air. When it's, say, in the air out here, it's like 10 degrees out, and that's, you know, in a day like this, the heat pumps generally defer. They can't keep up with things, so they defer to electric backup that's built into the heat pump, and that's when your power bill starts going nuts.
Can't you also tie in a solar collector into the hydronic system so that you could have like preheated?
Oh yeah, absolutely, absolutely. That's the reason I didn't do it is because when I was married, we both didn't want to. I didn't want to cut any trees. At that point, they were all growing, maturing trees, but they weren't mature. There's beautiful maples and oaks and everything, and it really did not want to have to cut. Several would have had to have been cut to do it right. Now they're starting to die. So, you know, it looks like an opportunity. Now, I don't want to ever, I don't cut live trees if they don't have, you know, just for the heck of it. I mean, it has to be a good reason. In this case, they're going to be on my house in 5 years, so they have to come down. So, yeah, preheating the water with thermal solar panels is an excellent way to do things, because that water is going to come in hot and or warm anyway, and it will help a whole lot in energy. You know, in fact, when they do that, they have to actually reset the boilers, because the boilers aren't used to that much heat coming in. They're set at water at 45 degrees Fahrenheit. Now you're introducing it at 110, which is like, whoa, you know, what's going on here? So they have to reset everything. But yeah, absolutely correct. Yeah, there's a lot of little things that work that way.
Is that called geothermal?
Well, the heat system we talked about in the ground is, yeah. And they usually dig trenches in the ground. Sometimes they dig wells, which are vertical. And sometimes if you have a water source like a pond, that's even more efficient. They actually sink tubes into the pond, and they circulate the fluid through the tubes, which is in the water, which actually is even more efficient. So, and they do it that way. They're buried about 2 to 3 feet in the soil. You know, you don't know they're there. So anyway, the efficiency is the other half of the equation, and that's you know, very, very important. Conservation is important, but efficiency is even, you know, equally important. So between the two of them, you know, that's our path we can travel in. Conservation is a no-brainer. It doesn't take a whole lot of thought or knowledge even to do that. You know, if you turn the thermostat down, you put a sweater on, you're saving energy. But efficiency is a little more complicated, because you have to figure stuff out. You know, with the kilowatt meter, and economically, is this $1,100 refrigerator worth it as opposed to the $790 one? Am I going to save that much if it's a third more efficient? You know, that kind of thing. So, and there's websites that'll do that calculation for you. There's the federal government has some excellent sites that just do that, can figure out cost calculators, and there's other sites that, you know, you just have to Google cost calculator appliances, energy efficient, or any combination of those words, and you'll get it. You know, it'll come up.